Okay, so we want to find the equation of the line and slope-intercept for the line that passes through these 2 points. So the first thing we'll do is find the slope, which would give us 12 minus b over 8 minus 4 is equal to 12 minus b over 4. So we can then put that right into point slope form with y minus 12 is equal to our slope, 12 minus b over 4 times x minus our x-coordinate, or 8. To get it into slope-intercept form, we're going to multiply out and isolate the y. So we'll start by distributing on the right side. Y minus 12 equals 12 minus b over 4 times x minus 8 over 1 times 12 minus b over 4. And what we can see is that the 8 and the 4 will cancel out to leave us with 2. And so this will then become y minus 12 equals 12 minus b over 4 minus 2 times 12, or 24, minus 2 times negative b, or plus 2b. And then we bring the 12 over to get y is equal to 12 minus b over 4, now minus 12 plus 2b. Okay, so if b is equal to negative 2, what are the x and y intercepts? Well, from the slope-intercept form, we already know that our y-intercept is equal to negative 12 plus 2b. So our y-intercept is going to be equal to negative 12 plus 2 times negative 2, or equal to negative 16. When we plug in, we want to now find our x-intercept. We need to set y equal to 0. So we're going to set 0 equals 12 minus b, we said, so negative 2, over 4. By the way, there should be x's up here. X's here. Times x minus 12 minus 4. Okay. So that gives us 0 is equal to 12 plus 2, or 14 over 4x minus 16, which gives us 16 is equal to 7 over 2x, and therefore we get 32 is equal to 7x, x is equal to 32 over 7. Okay, so we have our two intercepts. We have y at 0, negative 16, and x at 32 sevenths, comma 0. Okay, so moving right along. We want to find the equation of the line in intercept form that is a perpendicular bisector of segment AB, where A is equal to 2, 2, and B is equal to 4, negative 6. And we'll make a very, very rough sketch. And so we'll draw a little line here, a little coordinate plane, and we'll have 2, 2 be here, and we'll have 4, negative 6 be here maybe. We'll draw this segment here, and the midpoint would be about here, and our perpendicular bisector would look like that. Okay, so the slope of our line here is, we have a negative 6 minus 2 over 4 minus 2 is going to give us negative 8 over 2 is equal to negative 4. So that means the slope of our perpendicular bisector is going to be 1/4. And we also know it has to pass through the midpoint. And so we know that we have 2, 2 and 4, negative 6. So what I like to do is think of, all right, half the distance from an x of 2 to an x of 4 is going to leave us to an x of 3. And half the distance vertically from 2 to negative 6 is going to give us a y value for that halfway point of negative 2. And so now we have that y minus negative 2, or y plus 2, is equal to 1/4 x minus 3, or y plus 2 is equal to 1/4 x minus 3/4, and then we subtract 2 from both sides, we get y is equal to 1/4 x minus 3/4 minus 2, and 2 we know is equal to 8/4, So we're going to get with -3/4 minus 8/4. So that's going to give us minus 11/4. So that actually is our y-intercept. Our x-intercept is what we get when we replace y with 0. So we get 0 equals 1/4 x minus 11/4, or we get 11/4 equals 1/4 x. Multiply both sides by 4 to get 11 equals x. So our intercept form is then x over our x-intercept of 11 plus y over our y-intercept, which is negative 11/4. So I could write it like this: y over negative 11/4 is equal to 1. Or I could write it x over 11 minus y over 11/4 is equal to 1. So either one. This one keeps the information more compartmentalized because we have our x-intercept as 11 and our y-intercept as negative 11/4. Okay, assuming that both a and b are positive integers with no common factors, put x over a plus y over b equals 1 into standard form. All right, so we already have our x term and our y term on the same side, so that's an advantage. But what we want is we want to get rid of these fractions. So to find the least common denominator, we're just going to multiply a times b to give us ab. And so when I multiply ab times x over a plus ab times y over b equals ab times 1, I'm going to end up with the a's canceling out, so I end up with bx plus the b's canceling out, ay is equal to AB. Okay, so that's my standard form, and we already were told that A and B are positive integers, so we know that this B is positive, so that works as well. Okay, so the -8, and next problem we have that find the equation of the line that passes through 0, 0 and is perpendicular to the line in number 3. Okay, so the line in number 3 again was bx plus ay is equal to ab, which means that ay is equal to negative bx plus ab, and y then is equal to negative b over ax plus ab. And so the slope of the line that's perpendicular to this is going to have, we're going to have a slope of AB, the negative A over B, this is the negative reciprocal. And so now we're going to have y is equal to AB x plus the y-intercept of our line, but we already know that's equal to 0 because it passes through the origin. So this is our line, y equals A over bx. So one note here is that any line that passes through the origin when it's in the slope-intercept form is just going to be y equals mx, and that means because our y-intercept is always going to be equal to 0. Okay, so let's take a look at this next one. So this airplane starts with 5,000 gallons of fuel and burns 500 per hour, and so F of h is the amount of fuel left after h hours, and that's going to be equal to negative 500h because we are losing fuel for every hour that we're in the air, plus our original amount of 5,000. And what that means is that we have no more than 10 hours of flying, and we should remember that. Okay, but now we're asked, suppose that fuel costs $4.50 per gallon plus a one-time charge of $1.75 for filling the plane. So if C of h represents the total cost of the fuel used in h hours of flying, come up with an expression for C of h. Okay, so now the cost of flying is going to be equal to, so C of h is equal to 175 plus the number of hours we've been flying, but we're spending 500 gallons per hour, and so it's going to be 500 times h to represent the number of gallons, but then we have to multiply that by 450 to figure out the cost. So we end up with this, C of h is equal to 175 plus 500 times 450h, or 2250h plus 175. And so that gives us an output in dollars, and the input is in the number of hours. Okay, so we said that the inverse of a linear function, and again, this is something we'll talk about a lot more in general about functions. Basically, if we have something like y equals 4x minus 7, what we've done is we've taken x, we've multiplied it by 4 and subtracted 7. So now what we're doing is we're taking a value, x, we're adding 7 to undo the subtraction of 7, and then we're dividing by 4. And so we're saying that these two are inverses of each other. Y equals 4x minus 7, y equals x plus 7 over 4. So for example, if x is equal to 10, then y is equal to 4 times 10 minus 7, which would give us 33. And if we plug 33 into our other function here, we're going to get y equals 33 plus 7 over 4, and that's going to be equal to 10, and we're right back at our original value. Another way to think of it is that if we now solve this function here for x, we're going to get first 4y is equal to x plus 7, and therefore x is equal to 4y minus 7. And what you can see is that we just have our original function, but with the variables swapped. Okay, so we're now to find the equation in slope-intercept form of the inverse of y equals 3x plus 5. And so when we do that, we can say, all right, we know that the inverse of that is going to be, we'll think about it two ways. One is we can say, all right, we multiplied by 3 and added 5. So we could say our inverse would be we take x now, we subtract 5, and we divide by 3. That's going to be the inverse. And in full slope-intercept form, we'd have y equals 1/3 x minus 5/3. Okay, so the x and y intercepts of both functions, the original and its inverse. So for the original function, y equals 3x plus 5. So we would have a y-intercept of y equals 3x plus 5. So our y-intercept would be 5. And our x-intercept would be the value we get when we set y to 0. So we get 0 equals 3x plus 5. And that would give us negative 5 equals 3x. So x equals negative 5 over 3. Okay, so those are our x-intercept and our y-intercept. For our inverse function, well, we already know it's y equals 1/3 x minus 5/3. So our y-intercept is going to be equal to negative 5 over 3. And our x-intercepts, well, you can probably guess, but when we set y equal to 0, we get 0 equals 1/3 x minus 5/3. So when we add 5/3, we get 5/3 equals 1/3 x, and therefore x is equal to 5. So we get our two intercepts, x-intercept of 5, y-intercept negative 5/3, and those are just the opposites of the ones that we got for the original inverse, or for the original function, sorry. Okay, find the equation of the inverse of y equals mx plus b. So basically we're saying we multiplied by m and then added b. So we're going to say we subtracted b, and then we divided by m, or we could say 1 over m x minus b over m. And that would be the inverse function. Earlier was 1 over mx minus b over m. Okay, so now what we're being asked is to find the, we found the intercepts of both, so that's a repeat question. What is the intersection point? Okay, so this one gets a little more challenging. So we have y equals mx plus b, and we have y equals, again, our inverse here, as we so 1 over mx minus b over m, and we have to find where these two are equal to each other. Okay, so we're going to set mx plus b is equal to 1 over mx minus b over m. All right, let's get the x terms on one side, and so we get mx minus 1 over mx is equal to negative b over m minus b. So when we factor out, we get x equals m minus 1 over m at is equal to negative b over m minus b. Okay, so this is going to give us x is equal to negative b over m minus b over m minus 1 over m. All right, let's do a little work on these, both of these. Let's get both the numerator fractions to have the same denominator and the denominator fractions to have the same denominator. So that'll give us negative b minus b times m over m over m squared minus 1 over m. Okay, and so in the end, what that's going to give us is, we can cancel out the m's here. We're going to get negative b minus bm over m squared minus 1, or we could say it's b plus bm over m squared, or I'm sorry, over 1 minus m squared. So that would be our x coefficient for the inverse. For the y, we would then have to plug this in and solve for y. I'll leave that aside for now, and I'm going to continue on to the next. Okay, so here we have px plus 3y equals 10 and 5x minus qy equals 2 are parallel lines, and we're to express p in terms of q. Okay, so in order to do that, we know that these lines have to have the same slope. So we need to figure out what the two slopes are and then set them equal to each other. So in order to do that, we will say, let's get these both in slope-intercept form. So we can say that 3y is equal to negative px plus 10, and y is equal to negative p over 3x plus 10 over 3. Over here we have 5x equals 5x minus 2 equals qy, and so that means that we can say that y is equal to 5 over qx minus 2 over q. Okay, so we can now say that negative p over 3 must be equal to 5 over q in order for these two lines to be parallel, and we want to isolate p and have it expressed in terms of everything else. So we'll first multiply everything by 3. We'll get negative p is equal to 15 over q, and then multiply by negative 1 to get p is equal to negative 15 over q. So in order for these two lines to be parallel, this relationship must hold true. All right, next, list 3 points that are equidistant from points a equals 2, 5 and b equals 8, negative 3. Okay, so let's just make a quick sketch here. Very rough. So we have, let's see, 1, 2, and 3, 4, 5, 6, 7, 8. So we have 1, 2, 3, and we have 1, 2, 3, 4, 5. So we have 2, 5 at around here. We have 8, negative 3 at around here. And basically what we're saying when we're looking for all the lines that are equidistant from these 2 points is we want to find all the lines that lie on the perpendicular bisector of these two. Okay, so halfway from 2 to 8 gives us an x value of 6. I'm sorry, an x value of 5. And our y value halfway from 5 to -3 is going to give us a y of +1, even though it doesn't look that way on our very rough graph. So we also know that the slope of this line that connects A and B is going to be equal to -3 over 5, or -3 minus 5 over 8 minus 2 is going to give us -8 over 6. Okay, so we have a slope then of -4 over 3, and so our perpendicular line is going to have a slope of 3/4, and it passes through the point 5, 1, so we know that it has the equation y minus 1 equals 3/4 times x minus 5, or y minus 1 equals 3/4 x minus 15/4. And then if I add 1 to both sides, we get y equals 3/4 x minus, I can actually erase this, minus 11/4, because I added 1 to both sides, which is equal to 4/4. Okay, so we get y is equal to 3/4 x minus 11/4. So for 3 points, I can just start to plug in some values for x here. So we'll say that if x is equal to 4, when I plug that in, I'll get y equals 3/4 times 4, or 3, minus 11/4. So I would have 3, which is 12/4, minus 11/4, so this would be 1/4. I could also say when x is equal to 8, we get y is equal to 3/4 times 8, which would be 6, minus 11/4. So we have 24/4 minus 11/4, so this would give us 13/4. And let's say we would pick what happens when x is equal to 0. We would just get a y value of -11/4. Okay, so here we have 3 points. So as long as they fall on this line, they work for us. Okay, next one. So again, this should say find the equation of the median from A to BC. And that's not what it actually said, but so the median from A to BC, so it goes from A, 10, 5, to the midpoint of B and C, and so we have B is equal to 2, 11, and C is equal to 15, 0. So we're looking for the midpoint of 2, 11, and 15, 0. And so halfway from 2 to 15 gives us 8.5. Halfway from 11 to 0 gives us 5.5. So we're looking for the line that connects 10, 5 and 8.5, 5.5. The slope is going to be 5.5 minus 5 over 8.5 minus 10, which is going to give us 0.5 over 1.5, negative 1.5, or negative 1/3. And we know that it has to pass through the point 8.5, 5.5, so we could say y minus 5.5 equals negative 1/3 times x minus 8.5. And if we want it in slope-intercept form, we get y equals 5.5, or I'm sorry, y minus 5.5. And that's going to be equal to negative 1/3 x minus negative, so it would be negative 1/3 times negative 8.5, which would give us a positive, and this is 17 over 2, so we'd end up with a positive 17 over 6, which would y is equal to negative 1/3 x plus 17 over 6 plus 5.5, which is equal to 11 over 2, or 33 over 6. So we would get y is equal to negative 1/3 x plus 50 over 6, or y is equal to negative 1/3 x plus 25 over 3, which is equal to 8 1/3. Okay, so that's the equation of our median. At least I hope it is.